According to the National Electrical Code, specifically NEC 300.3 bone, conductors of different systems, circuits, or classes of voltage must not be contained in the same raceway, cable, or other enclosure unless permitted elsewhere in the code. Additionally, NEC 300.12 states that conductors of different systems, circuits, or classes of voltage must not be installed in the same cable, raceway, or other enclosure. There are exceptions to this rule. One exception is that conductors of different systems, circuits, or classes of voltage are permitted in the same cable, raceway, or other enclosure if they meet certain requirements. Firstly, all conductors must be insulated for the maximum voltage of any conductor within the enclosure. Secondly, the cable must be listed and marked as multi-rated for the voltages and systems present. Thirdly, the raceway, cable, or other enclosure must be listed and marked as multi-rated for the voltages and systems present. Now, let's consider a scenario involving a customer who has had motion sensors installed in their offices by a lighting service company. The 2x4 troughers are fed with snap wiring, and the contractor installing the sensors is tapping into the existing switch pack for power and a switch leg for their control device. The problem is that the switch pack lacks a neutral connection, so the contractor is obtaining a neutral for their control device from a nearby 2x4 trougher, using the white wire from a 12/2 metal-clad cable, abbreviated MC, to complete the neutral connection back to the motion sensor control device. Providing the neutral in this manner raises code compliance concerns. According to the NEC, the described method of using the white wire from a 12/2 MC cable to provide a neutral for the motion sensor control device from a nearby 2x4 trougher is not permitted. The white wire in a 12/2 MC cable is specifically intended to serve as the neutral conductor for a 120-volt circuit. Using it to provide a neutral for a different system, such as a motion sensor control device, is a violation of both NEC 300.3 bone and 300.12a. The proper way to provide a neutral for the motion sensor controlled device is to run a separate 12/2 non-metallic sheath cable, abbreviated NM, directly from the panel to the device. This ensures that the conductors for the motion sensor control device are electrically isolated from the conductors serving the lighting circuit, maintaining code compliance and promoting electrical safety. To elaborate further on why this practice is a violation, it's important to understand the intent and purpose of the NEC regulations. The code aims to prevent situations where different voltage systems or circuits could potentially interfere with each other, creating safety hazards or causing equipment malfunction. Using a shared neutral between different systems can lead to problems such as voltage imbalances, harmonic distortion, and increased risk of electrical shock. In the specific scenario described, the lighting circuit and the motion sensor control circuit are considered separate systems. Tying their neutrals together creates a situation where current from one system can potentially flow through the neutral conductor of the other system, which is not designed for that purpose. This can overload the neutral conductor, leading to overheating and potentially causing a fire. The NEC provides clear guidelines on how to properly separate different electrical systems to prevent these types of issues. By requiring separate wiring for different systems, the code ensures that each system has its own dedicated conductors, including the neutral, which are properly sized and rated for the specific load they are intended to carry. In the case of the motion sensor control device, it should have its own dedicated neutral conductor that is run back to the electrical panel. This neutral conductor should be sized according to the load requirements of the motion sensor control device and should be properly connected to the neutral busbar in the panel. By following these guidelines, the risk of electrical hazards is minimized and the integrity of the electrical system is maintained. It's also worth noting that using a shared neutral between different systems can create problems for troubleshooting and maintenance. If there is a fault in one system, it can be difficult to isolate the problem if the neutrals are tied together. By keeping the systems separate, it is easier to identify and resolve any issues that may arise. Furthermore, using the white wire from a 12/2 MC cable for a purpose other than its intended use as a neutral conductor violates the NEC requirement that conductors be identified by color coding. The white wire is specifically designated as the neutral conductor, and using it for any other purpose can create confusion and increase the risk of electrical shock. In summary, the practice of using a shared neutral between different electrical systems, as described in the scenario, is a violation of the NEC and can create significant safety hazards. The code requires that different systems be kept separate, with each system having its own dedicated conductors, including the neutral. By following these guidelines, electrical safety and code compliance are ensured. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. When working with electrical systems, it is always important to consult with a qualified electrician and follow all applicable codes and regulations. Let's further explore the implications of NEC 300.3 burn and 300.12 in the context of this specific scenario. These sections of the code are designed to prevent the mixing of different electrical systems within the same enclosure or raceway, unless certain conditions are met. The rationale behind this is to minimize the risk of interference, voltage conflicts, and potential hazards that can arise when different systems share common pathways. In the case of the motion sensor installation, the lighting circuit and the motion sensor circuit are considered separate systems due to their distinct functions and voltage requirements. The lighting circuit typically operates at 120 volts alternating current, and its primary purpose is to provide illumination. On the other hand, the motion sensor circuit may operate at a different voltage or utilize a different type of signal for control purposes. By tapping into the lighting circuit to obtain a neutral for the motion sensor, the contractor is effectively mixing these two systems, which is a violation of NEC 300.3 BON and 300.12a. Even though the motion sensor may seem like a small and insignificant load, it is still considered a separate system, and its wiring must be kept isolated from the lighting circuit. The exception to this rule, as mentioned earlier, is that conductors of different systems are permitted in the same enclosure if they meet certain requirements. These requirements include ensuring that all conductors are insulated for the maximum voltage present, the cable is listed and marked as multi-rated, and the enclosure is listed and marked as multi-rated. However, in the scenario described, these requirements are not met. The 12/2MC cable used by the contractor is not listed or marked as multi-rated for different systems. It is specifically designed for use in single-circuit applications where the white wire serves as the neutral conductor for that circuit. Using it to provide a neutral for a different system violates the code and can create safety hazards. Additionally, it's important to consider the potential for voltage conflicts when mixing different systems. If the motion sensor circuit operates at a different voltage than the lighting circuit, there could be a voltage potential between the two systems. This voltage potential can cause current to flow between the systems, leading to interference, equipment malfunction, or even electrical shock. By keeping the systems separate, the risk of voltage conflicts is minimized. Furthermore, the use of a shared neutral can create problems with grounding and bonding. Grounding and bonding are essential for electrical safety, as they provide a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. When different systems share a common neutral, it can compromise the effectiveness of the grounding and bonding system, increasing the risk of electrical shock. In summary, the practice of using a shared neutral between different electrical systems, as described in the scenario, is a clear violation of NEC 300.3 BON and 300.12a. The code requires that different systems be kept separate, with each system having its own dedicated conductors, including the neutral. By following these guidelines, electrical safety, code compliance, and proper system operation are ensured. It is crucial for electrical contractors and installers to have a thorough understanding of the NEC and to adhere to its requirements when performing electrical work. Failure to do so can result in safety hazards, code violations, and potential liability issues. In addition to the specific code sections mentioned, there are other NEC articles that may be relevant to the scenario. For example, Article 200 covers the identification and use of grounded conductors, including the neutral. This article specifies that the neutral conductor must be white or grey in color and must be used only for carrying neutral current. Using the white wire for any other purpose violates this requirement. Another relevant article is Article 250, which covers grounding and bonding. This article provides detailed requirements for grounding and bonding electrical systems to ensure electrical safety. The proper grounding and bonding of the motion sensor circuit is essential for preventing electrical shock and ensuring proper system operation. Furthermore, Article 300 provides general requirements for wiring methods and materials. This article covers topics such as the proper installation of cables, raceways, and enclosures. It also specifies that wiring must be protected from physical damage and installed in a neat and workmanlike manner. In the context of the motion sensor installation, it is important to ensure that the wiring is properly installed and protected from damage. The 12/2 cable should be securely fastened and supported, and it should not be exposed to excessive heat or moisture. In addition to complying with the NEC, it is also important to follow any local codes and regulations that may apply. Local codes may have additional requirements that are not covered in the NEC. It is the responsibility of the electrical contractor to be aware of and comply with all applicable codes and regulations. Furthermore, it is important to use listed and labeled equipment for all electrical installations. Listed equipment has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories UL to meet certain safety standards. Using listed equipment ensures that the installation is safe and reliable. In the case of the motion sensor installation, it is important to use a motion sensor that is listed and labeled for its intended use. The motion sensor should be installed according to the manufacturer's instructions and should be properly grounded and bonded. In summary, the proper installation of motion sensors requires a thorough understanding of the NEC local codes and manufacturer's instructions. It is essential to follow all applicable codes and regulations to ensure electrical safety and proper system operation. The use of a shared neutral between different electrical systems is a violation of the NEC and can create significant safety hazards. By keeping the systems separate and using dedicated conductors for each system, electrical safety and code compliance are ensured. Let's delve deeper into the practical implications of this code violation and explore the potential consequences that can arise from improper wiring. Firstly, consider the increased risk of electrical shock. When a shared neutral is used, the grounding path for the motion sensor circuit may not be as effective as it would be with a dedicated neutral. This can increase the risk of electrical shock if there is a fault in the motion sensor or its wiring. If someone were to come into contact with a live wire in the motion sensor circuit, the fault current may not flow back to the source quickly enough to trip the circuit breaker. This can result in a prolonged electrical shock, which can be life-threatening. Secondly, there is the potential for equipment damage. The shared neutral may not be able to handle the combined current from both the lighting circuit and the motion sensor circuit. This can cause the neutral conductor to overheat, which can damage the insulation and potentially start a fire. Additionally, the voltage fluctuations caused by the shared neutral can damage sensitive electronic components in the motion sensor or the lighting fixtures. Thirdly, improper wiring can create problems with troubleshooting and maintenance. If there is a fault in either the lighting circuit or the motion sensor circuit, it can be difficult to isolate the problem if the neutrals are tied together. The fault current may flow through both circuits, making it difficult to determine the source of the problem. This can lead to prolonged downtime and increased repair costs. Fourthly, there is the issue of code compliance. As we have discussed, the use of a shared neutral is a clear violation of the NEC. This can result in fines, penalties, and even legal action. If the installation is inspected by a code official, they will likely require the contractor to correct the wiring and bring it into compliance with the code. This can be a costly and time-consuming process. Fifthly, there is the potential for liability. If someone is injured or property is damaged as a result of the improper wiring, the contractor could be held liable. This can result in significant financial losses and damage to the contractor's reputation. In light of these potential consequences, it is clear that the proper installation of motion sensors is essential. Electrical contractors and installers must have a thorough understanding of the NEC and must adhere to its requirements when performing electrical work. The use of a shared neutral between different electrical systems is a dangerous and illegal practice that should be avoided at all costs. To further illustrate the importance of code compliance, let's consider a real-world example. Imagine that a fire breaks out in an office building due to faulty wiring. The investigation reveals that the fire was caused by a shared neutral between the lighting circuit and the motion sensor circuit. The shared neutral had overheated and ignited nearby combustible materials. As a result of the fire, several people are injured and the building sustains significant damage. The insurance company refuses to pay the claim, citing the code violation as the cause of the fire. The building owner sues the electrical contractor for negligence. The court finds the contractor liable and orders them to pay damages to the injured parties and the building owner. In this example, the contractor's failure to comply with the NEC resulted in a devastating fire and significant financial losses. This highlights the importance of taking code compliance seriously and ensuring that all electrical installations are performed in a safe and workmanlike manner. In conclusion, the proper installation of motion sensors requires a thorough understanding of the NEC local codes and manufacturer's instructions. It is essential to follow all applicable codes and regulations to ensure electrical safety and proper system operation. The use of a shared neutral between different electrical systems is a violation of the NEC and can create significant safety hazards. By keeping the system separate and using dedicated conductors for each system, electrical safety and code compliance are ensured. Always consult with a qualified electrician before performing any electrical work.